This is Unit 4, Lesson 4. The purpose of this lesson is that you will learn more about ordering the sides and the angles of a triangle using what is given to you. The first theorem allows you to order the angles based on the sides. It says if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So the larger angle is across from the longest side. Have an animation. So here's a triangle. What it's done is I've told it to highlight the largest angle and largest side. So we have an angle of 37, that's the smallest, an angle of 70, that's the middle, and an angle of 73. Notice the side lengths. The side lengths are 18, so the smallest angle, shortest side. The in-between was 70, 29.5. And then the longest side and the largest angle are across from each other. So we're looking diagonally. What's nice about this animation, and it's on my website, is that you can click it to show the smallest angle. So in this particular case, and we can change the diagram around too. Let's do that. The angles are 53, 58, and 68. So this is definitely the smallest angle. And look across. Its side length is the smallest out of 18, 19, and 21. So the theorem is simply stating that you can order the lengths and the angles by given, depending on the information you're given. So something else that might be worthy to jot down is that the smallest angle lies opposite the shortest side, which I already mentioned, showing that animation. And then the converse says that if two angles of a triangle are not congruent, then the larger side lies opposite the larger angle. So same concept, just backwards. Basically, it's these headings right here. If you're given sides, then you can order angles. If you're given angles, then you can order sides. And then here's one more thing to jot down. So longer side lies opposite the larger angle. Shortest side lies opposite the smallest angle. So it all depends what you're given first. I copied the pictures that I had from the previous lesson to show side, opposite, and angle. When we talk about opposite, you're going across the diagram. I really like this second one because it's highlighting that here's the angle, here's the side that's opposite, and it's going across from a certain point. All right, so go ahead and try it. It says list the angles. So when you do this, be careful of what it's asking you. So angles, so we're going to need the angle notation from the smallest to the largest. Well, we want angles, but they gave us sides. This is the smallest, the next smallest, and the largest. So that means that this angle must be the smallest angle, that this angle must be the in-between, and that angle B is the largest. So just be careful of your notation. Letter B says list the sides of triangle ABC from the shortest to longest. So when we deal with sides, we're talking about two letters with the side length over top. They only gave me 2 of the 3 sides, but I know that triangles add up to 180. Using my calculator, I determined that angle Y ended up to being 80 degrees. So I need side lengths. Well, let's first start with angles. That's the smallest angle, the next smallest angle, and the largest angle. So the smallest side lies opposite the smallest angle. So that means that side YZ is the shortest. It's not asking you how long it is, it's just asking you to order them from smallest to longest. 60 is the next smallest angle, and the side that's opposite of it is XY. And then the last one is angle Y, and the side across or opposite it is XZ. Be careful of notation. We're talking about line segments. Lastly, in letter C, it says in triangle PRQ, angle Q is a right angle, and which is the longest side? Draw it. So here's P RQ, and it's telling me that Q is the right angle. So the side opposite the right angle is PR, which is referred to as the hypotenuse, which we know is always the longest side. The next question I'm posing is, can any three segments form a right triangle? So lesson 4, I have a couple of animations. This first one shows a couple of line segments. Just because you have 3 segments doesn't mean they're necessarily going to connect to form a triangle. And this one's not super interactive where it's allowing you to change the segment lengths, but those 3 segments don't form a triangle. So back in our notes it says, can a triangle be formed with length 3 inches, 3 inches, and 5 inches? So if you were to have a line segment of 3 inches, another one of 3 inches, and one of 5 inches, could you manipulate these in a way so that you could actually make a triangle? And I have an animation that does that. So let's see what we can do. Here's 5. And let's get these to both be 3. Oh, I just had it there. So yes, 5, 3, and 3 can form a triangle. And 6, 2, and 2. So let's make this one a little bit bigger. And go in through here. It's not allowing me to make it any smaller, because this is an example where if you had something of 6 and then 2 and 2, if you were to arrange these, they're not going to give you a triangle. So there's got to be a way to determine this without using an animation. And what it is it's the triangle inequality theorem. What the triangle inequality theorem does is, remember from algebra, an inequality uses those symbols. It says the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. So take 2 sides of a triangle, 3 plus 3, and it's telling me that it has to be greater than 5. 6 is greater than 5, so that's a true statement. Try it again. Take 2 side lengths. This time I'm going to use 3 and 5. So 2 side lengths have to be greater than the third. 8 is greater than 3. That's a true statement. This problem's a little bit different because the other combination would be here, which is the same as what we just did. Yes, that's a true statement. Go ahead and try all 3 inequalities over here. If I were to do 2 plus 2, 2 plus 2 is not greater than 6, which is why this triangle, those side lengths are not a triangle. Last one. It says a triangle has side lengths of 8 and 10. Describe the lengths of the third side. So we need to add these up. If we take 8 plus 10, it has to be greater than what? Try a different combination. 8 plus what has to be greater than 10? And there's a third combination. 10 plus what needs to be greater than 8? Set it up and solve. This is telling you that x has to be less than 18. If I get x by itself, x has to be greater than 2. And if I try the third one, doesn't make any sense, can't have a side length of -2. So this is giving you, it's called a compound inequality, if you remember that from Algebra 1. It's telling you that x has to be between 2 and 18. So that it is larger than 2. Notice the open end is going to the x. And it has to be smaller than 18. So you could have a side length or a triangle that consisted of, well, it can't be equal to, so 2.3, 8, and 10, that would fit. You could have anything there, let's see, 3. You could have a side length of 17 as long as it didn't actually equal 18. And if you tried it with any of these combinations, it's going to make it true. So let's try it with one. So I said it needs to be a 3 would work. So if I use 3, 8, and 10, 3 plus 8 is larger than 10. True. 8 plus 10 is larger than 3. True. And 10 plus 8 is, I already did that combo. I need 3 and 10 is greater than 8. So because it was true for all three, we know that those 3 side lengths must form a triangle. Go ahead and try this next one, titled You Try. I wrote over it, and that concludes lesson 4 from Unit 4.